Hi, my name is Marsha. I'm the blonde from Coding Blonde, and today I want to talk about big data and what it actually is. So I have interviewed Lillian, who you might already know as a big data girl on Instagram, who is a serial entrepreneur in tech, who is a data scientist and consultant working with multiple Fortune 100 companies, and who is a total inspiration for me. During our interview, Lillian gives an awesome introduction into big data, what it is, and uses a specific example to show how companies can benefit from using it. And she also shares awesome tips and advice on how you can get into the industry if you're a beginner. So let's get straight to the interview. Hi again, Lillian. Thank you so much for finding time to come to my channel and talk about big data.
Yay, thank you for having me. This is my favorite topic. I can talk data all day.
Well,
Do it.
let's jump straight into it. I feel like it can be mysterious for some people who don't understand what it is. Could you please explain what is big data?
Okay, so there are several different definitions for quote unquote big data. So some people go with the three V's, which are like a sufficient variety of data, either structured, semi-structured, or unstructured, or sufficient volume. Say your project requires more than a terabyte of data, then that would be a big data project. Or sufficient velocity. So if you are working with streaming data, then you're working on a big data project because you can't use traditional data technologies to really create value from streaming data. So that's one of the definitions. The other definition is that if you're working on a project, you're planning an implementation that requires you to acquire one of the newer big data engineering technologies like Hadoop, MapReduce, Spark. There's a whole plethora of technologies. If you have to acquire one of these new technologies in order to implement your use case, then that would be considered a big data project. So that's the Dell definition, and I really like that definition actually.
I like that you use different definitions for this topic, and you kind of touched upon that. But what kind of data exists out there? What is data that you're collecting, kind of thing, and what can one do with data?
Okay, so that's a really broad question. I will start by saying that raw big data is very low value. So what you pretty much have to do to create value, what you can do with big data is create business value. You can create all types of value. You could create lifestyle insights. You could create, humanitarian response insights to improve performance in humanitarian response processes. There's all sorts of application areas, but the number one thing is that the data, big data, raw big data needs to be processed because in its raw form, it's very low value. And then to really be able to answer your question clearly, can we talk about a use case? So can you narrow down maybe frame your question around a specific type, like it's a retail business or humanitarian project or something where I can actually kind of bring in the context, because it's such a really wide space that I can't talk about it without narrowing in.
Of course. Yeah, maybe retail would be a good example and easy to visualize for anyone. Yeah, retail, maybe ASOS. It's an online store or any online store like Topshop, Zara, kind of thing.
Okay, and so we'll say e-commerce, online retail. And then what was the question?
So what kind of data exists for, I guess, these kind of companies that they can collect, and how can they process it? How can they use it?
To process how to use it. Okay, great question. So we're talking about the online retail space, and the first question was about data, like what type of data is available. So really what you're pointing at here is data resources. And so you could have clickstream data. You can have data from your customer behavioral data, how customers are behaving on your website. You also have ways to track visitors and whether or not they're actually existing customers, and so that you could tie in their behavior, their purchase history with their current behavior. So you've got a whole series of real-time data via clickstream that you can create. You can also, for retailers, there's also data coming in form of like search appliances. So people are entering their search queries. That's another form of data. And then you have all your business data, right? So you have your traditional transactional business data, the data you need to run your business, contracts, invoicing, all the things internal to your business. And then you have also your customer data, the demographics, the purchase history. And so when we're looking at this, you're definitely going to have a lot of data, but you're going to have structured data in terms of your business data, your customer, the purchase history data. This is mostly structured. And then when you get your clickstream data, it's coming in real time. It's unstructured. Of course, you could add structure, but like these, identifying the data types is important because these define the constraints of the technologies you need and the systems, the methods you need to apply to actually create the value. So we covered data resources, types of data you could use to create value in online retail. Now, how do you actually use it? So I'll point to two points here. You need data skill sets and data technologies. So for online retailers, of course, you want to monetize your customer touch points. So recommendation engines are a great idea. So I'll just say one use case would be recommendation engines. And then let's say the other use case would be, let's say you want to improve your search returns for better, like Walmart got a 10 to 15% improvement in decrease in shopping cart abandonment by improving the returns from their search appliance when users go and search their website. So say, okay, you want to improve your search results so that your customers are happier, they're less likely to close the page. So search improvement. So these are two use cases. And then you need to look at, we have our use cases defined. So what are the data science components? Like what skill sets do we need to build out recommendation engines, to build the model, to bring the model into production? Same thing with search improvements. What are the data science skill sets we need? And then also you have to identify the technology components, do an evaluation between competing technology components to support those use cases, and look at the data skill sets required for supporting that are required to implement on those technologies. So it really comes down to deciding the use case and then looking at the data resources and skill sets, and also data technologies you have available.
That's
Does that
awesome.
help?
Yeah, very helpful. And thank you very much for making it very specific to this one because it's easier to visualize for sure. And what do you do as a data scientist? I know this is pretty broad, but I guess like day-to-day stuff maybe is very...
This is fun. You guys are getting a sample of my, basically, this is quasi like data training and also data strategy. Okay, so data scientist, you know, if you're working as a high-level data scientist, then you're working on predictive models. You're building predictive models, and you're making predictions and prescriptions, recommendations to the business on what they need to do in order to achieve the desired outcome in the future. But the problem has become with big data that a lot of, well, there's several issues that need to be overcome. Data scientists are spending, like Crowdflower back in 2017, they have an annual survey of data scientists. Data scientists are reporting spending 65% of their time on data management, like data cleanup, data preparation tasks. This is work that actually could be automated Because the other factor here is that the average wage of a data scientist in the United States is $170,000 per year. So if you have these people that are great at building predictive models, but they're spending time like cleaning data, reformatting data, removing outliers, preparing it for analysis, all this stuff that could either be automated or kind of. So there's two strategies for overcoming this problem, but it's a big problem because you want to get the data scientists who are specializing in making predictions, building predictive models, spending their time on the higher value work. And then, so my recommendation for this problem is either to purchase a big data management platform that can automate your data preparation work and your data governance work, or build a tier of teams. So senior data scientists and junior data scientists, and have the junior data scientist, that's part of data science, is preparing data for modeling, preparing it for analysis. To have those junior data scientists supporting both analytics and senior data science, just doing the data preparation work mostly with a little bit of prediction, to kind of try and like tier out the pricing, because you don't want to pay someone $170,000 a year to massage data. That's not a very good strategy.
I agree. Sounds like it's a very, very pricey massage for the data.
Yeah, I mean, it's about trying, so this is where I really enjoy working on the overarching strategy, because there's so much value that can be had. And it is about creating value, but at this point, like the big players in industry have already adopted big data innovation, and they're already winning. So it's about like being able to stay competitive, and but it's expensive. So like, how do we do this? How do we create this value in order to stay relevant in the field without like breaking the bank? So yeah, if you are interested in going into data science or data engineering, there's plenty of room, and I don't think that's going anywhere necessarily per se. It's a good field to enter.
Yeah, and actually my next question was about how did you find your way into data science and what keeps you excited about it?
Okay, definitely. What keeps me excited? So I have an ebook that I published. It's called A Badass's Guide to Breaking into Data. And I basically detail all of the steps that I recommend a person take if they want to break into the field, based on my experience. But what I did was I did my reverse engineering thing. So I knew I love working with data. This was in 2012. I found out, oh my gosh, there's actually a field where you just get to, work with data all day and make predictions and find trends. And this is something that I love doing. So I realized, oh, this is actually a field. So I want to do this. I know I want to do this. This is my calling. So then I need to look up, what are the competencies if I wanted to work in this field? Well, I need to know Python. I need to know R. I need to get a little better in statistics. At this time, there were not online courses for data science, if you can believe that. There was like one, and it wasn't awesome. So I got some books, and I started teaching myself via books, and then kind of just one-off like courses that were related, like learn Python for geographic information systems and build predictive models that way. And then once I knew Python, I could easily use, try to find anything I could to fill those gaps within my existing role, because you need experience. So you need training, you need experience. And so the easiest way to do that is to, either try and get that on your own at night after work, or in your current role, or both. So that is actually what I did. I did both. But then by the time that I, was ready to move on from that role, I was already, the side hustle that I was building at night was already doing so well that I didn't need to get another job. There's a lot of demand. There's a huge demand in this field. So like especially for Americans, because mostly if you're like, mostly people that do data science or I think tech are coming from overseas. And so it's, if you're an American that knows how to work in these fields, it's like a big demand because they need people that can conduct business in America, right? So anyway, what else was the other question? What keeps me inspired? This is just, I don't need to be kept inspired. This is like this is data, like making predictions from data is a natural bent for me. So I've been doing this sort of thing since I was, even my first job, I was 16. They had me processing insurance claims for a dental office. And I was putting in the records and I was thinking about the people's birth dates. And I was thinking, I wonder if we had enough birth dates, if we could make predictions about, I was thinking about kind of like astronomy or astrology, whatever, sorry, I know there's a huge difference, but relating people's birth dates in mass to trends, quantitative trends about the people, trying to relate, it's just, this is just who I am. And so what keeps me inspired is that I don't really need to keep inspired because it's part of my personality, but I do get really excited with these newer technologies that I see coming out that are just so powerful, that increase the capabilities, like these automation platforms. I'm so excited about these data science automation platforms, which is weird for a data scientist to say, but I really want companies to get on to data science automation because you can make progress. I'm really excited about automation in general, but anyway.
That's awesome. Yeah, it's amazing that you came to that as a 16-year-old and that you were thinking about predicting and modeling, already then. It's awesome. It was definitely your calling for sure. And my final question, and you kind of answered that already, is what would you recommend for people who would like to get into data science in terms of resources and a place to start?
Okay, so when you say I'm going to develop a little more clarity. Get into data science, like get into like learning the field or get a job in the field, or
starting to learn at this point, just starting to learn the
I
skills.
think I really so I develop custom training plans for people who want to enter the field to take them from their existing skill sets to where they want to go, because I know all of the contingencies and all of the prerequisites. I know the field. So you could always hire someone to make you a plan, or you can go, as far as resources, you could go to, I like Udemy a lot. As a learner, I love Udemy because there's some amazing courses there and they're way underpriced. They're like $10.99. So as a learner, it's a great place to go. And then I also like this platform, Experfy. It's more expensive, but they've got a little more specialty. It's data professionals training data professionals. I know some people go over to RCamp or something like that. There's other platforms that are competing in the data space and they're just focusing on data and data courses. So you could look into that. But I think if you just go to Udemy and pay like $10.99 for a course and just start taking the good courses on there, you're going to learn a lot. Yeah. And then Coursera's got some good courses, and edX. You just have to look around. So I recommend courses from Coursera, Linda's. I recommend courses from Udemy. I pull recommendations. Actually, also some topics are not covered in online courses. So then I recommend books. So you really have to, this is where you really have to reverse engineer. Again, figure out what you want to do and then figure out what's required and then figure out, okay, what are the building blocks and start building it out from there. Because you can't just, there's no one-stop shop. And, but there are some really great alternatives out there.
That's awesome. And I guess your ebook is a great resource as well.
It's got a bunch of like course links, like if you want to go into data engineering or data science. So people need to also like, now it's fun, now it's better, but like maybe 4 years ago, you would go onto job boards and they would say, we're hiring a data engineer. And then you would look at the position description and they would be describing data scientists. And like that, it's not like that anymore. Now people are, you know, hiring people, they know how to write position descriptions, but like, you have to decide, like, even though I was a licensed professional engineer and I actually still, like, even at that time, I was like, what is the, someone asked me, like, define the difference between engineering and science. That's not, and I just was like, I don't really know. And I've talked to other engineers and they say the same thing and scientists say the same thing. So like, you have to understand the fundamental difference between engineering and data science and then figure out which are you better inclined towards. That's like the fundamental thing. Because if you're a programmer, already a developer, which a lot of people from Instagram already are developers, you may be a lot better suited for data engineering. And there's a ton of demand there too. So it may not be data science. You know what I'm saying? Data science is a really highly quantitative field.
Yeah, absolutely. And I'm sure it's super important to understand that distinction before you're going into it, because maybe you had something else in mind before
totally
starting. So guys,
it's exactly, start with like understanding what these actually are and if what you enjoy, and then think about mostly what are you going to enjoy, because a lot of the competencies can be covered by training, but you can't, if you get stuck doing a job you don't like doing, you can't, no amount of money in the world can buy back that time, you know, that you lost in joy that you could have spent doing something you loved.
Absolutely. Well, thank you so much, Lillian. This was awesome, and I hope the viewers have a much better idea of what a data scientist does, and if they want to get into the field, they have basically some steps to do so. Thank you very much.
Thank you for having me, Masha.
Thank you so much, Lillian, for that awesome introduction into big data and what you do as a data scientist, as well as tips and advice on how beginners can get into the industry. If you guys want to follow Lillian and follow her journey, make sure you do so on Instagram at BigDataGal. The active link will be in the description. And if you're serious about data science, make sure you sign up for her free ebook, Badass's Guide to Breaking into Data, which will also be linked in the description. Please let me know what you thought about this video in the comments. Where are you on your data science journey? And if you enjoy this video, make sure you like it and subscribe to my YouTube channel if you haven't yet. You can also find me on other social media at CodingBlonde. Have a wonderful time of the day you're currently experiencing. Bye.